Today we're doing section 5.2, so it's the first day in 5.2. We're still going to be verifying identities, just now we're going to introduce some new formulas that we're going to use. You will not have to memorize these formulas, you just need to know how to use them. It's in your best interest to write them down, so even if you typically don't take notes, please write these down somewhere so you can reference them. So these are the sum difference formulas. Again, you don't have to memorize, you just need to know how to use. Just so we are aware, this little symbol right here is our alpha. This is our alpha symbol. And this symbol right here is our beta symbol. Alpha and beta just is signifying that we have two different angles. So if you need to pause the video, please pause the video so that you can copy all these formulas down so you have them to reference in your notes. And then restart the video when you're ready for the next two examples. So here is our first example, and we're trying to verify that cosine of alpha minus beta, all divided by sine alpha cosine beta, is equal to cotangent alpha plus tangent beta. So we are going to work with the left side, and we're going to use our formulas. So we're going to use the formula that says cosine alpha minus beta. So we're going to replace that with what it's equal to. So it is equal to cosine alpha cosine beta plus sine of alpha sine of beta. And this is all over sine of alpha cosine beta. And as far as strategy goes, notice I have one big fraction on the left-hand side, two separate fractions on the right-hand side. So I need to separate this into two fractions. So they're both, when I split it up, they both get the denominator. So I will have cosine of alpha cosine beta over sine alpha cosine beta plus sine alpha sine beta all over sine alpha cosine beta. And after I separate it, I have to do some canceling. So notice in the left fraction, I have a cosine beta top and bottom. In the right fraction, I have a sine alpha top and bottom. And now I can go back, and cosine alpha divided by sine alpha would give me cotangent alpha. And over here, sine beta divided by cosine beta gives me tangent beta. So at this point, we've now verified the identity because we got the same thing on both sides. So you should find that these are a little bit easier to do. All right, our next and final example for today is going to be a little bit more involved than that last one. So here we have sine of alpha plus beta times sine of alpha minus beta, and this is equal to cosine squared beta minus cosine squared alpha. So again, we need to use the formulas here. So sine of alpha plus beta is going to be replaced with sine of alpha cosine beta plus cosine alpha sine of beta. And then we're timesing this with what sine of alpha minus beta is equal to. And essentially it's the same thing. It's just the sign is different. So it's minus, and then it's cosine alpha sine of beta. And from here we have to FOIL. So we're going to do our first, outer, inner, last. So if I multiply my two first terms, I'll have sine squared alpha cosine squared beta. In my inner and outer terms, you're going to notice, so this term and this term are going to be exactly the same, just one's positive, one's negative. So we know that those are going to cancel. So I don't need to write that down. But I know my last term will be there, And my last term would be cosine squared alpha sine squared beta. And now I need to look what I'm trying to prove. So notice I have sine squareds and cosine squareds on the left side. On the right side, I just have cosines. So my goal is I need to get rid of these sine squareds. So we can go back to that whole idea of our Pythagorean identities. So I know I can replace that, and I can replace this with what it's equal to. So a sine squared of alpha is equal to 1 minus cosine squared alpha. And then I still have that cosine squared beta out here. And over here I have my cosine squared alpha. And I'm going to replace this one with 1 minus cosine squared beta. And now I have to do some distributing here to clean it up. So I can distribute that one in, and I'll distribute this one in. So 1 times cosine squared beta will be cosine squared beta. Then I'll have minus cosine squared alpha cosine squared beta. Then I distribute my right hand one. So cosine squared times 1 will be cosine squared alpha. And then a negative times a negative is a positive. And I have cosine squared alpha cosine squared beta. And now I want you to look at these two terms right here. So here I have a negative cosine squared alpha cosine squared beta. And over here I have a positive cosine squared alpha cosine squared beta. So these will cancel. And I'm left with cosine squared beta minus cosine squared alpha, which is what we were trying to prove. So we have now verified our identity. So again, this one's a little bit more involved, but these tend to be a little bit more concrete because there's definite formulas that you have to use. So that's all for today. We'll pick up with this tomorrow.